If you look at pre-experimental designs, are very similar to the ones we conducted for sales training program. The first one shot study. What is happening? Who will tell me in the one shot study what is written? So we have an experimental group. Very good, Jayant. So there is, even the last set there is an impact. Very good. So there is experimental group only. Treatment is given at time t1, which is denoted by x, and after certain period of time at time t2 observation is taken. And what I have written below in red color, this is what will be the confounding or external variables that disturb the internal validity, that would not allow us to conclude that x is a cause of y, because their impact is also coming. History, HS, MA is maturity, SB is selection bias, MO is mortality. All these have impact in addition to X having impact on the observation. It is simply saying you gave the treatment and then you noted down the Y variable. Which means, let's say in the sales training program, you did not even take the readings before the sales training program. You gave the sales training program and then took the reading. Only one observation are taken post the experiment. That is what is one shot study.
So why is it called pre-experimental? We're still doing something.
It is not pre-experimental means we are not doing randomization, we are not doing matching of units, we are not doing randomization, we are not using control group. They are not the true way of conducting experiments. They are not the true way of conducting experiment. That is why they are written pre-experiment. They might act as a starter for your main course true experiment which will come. So this is just to get you started. Why we conduct one shot study? Because sometimes this context, our situations are such that we cannot have multiple groups and we cannot have pre and post. In real life, when we have to conduct experiments, we do not have the time, resources for having multiple groups sometimes and taking pre and post readings. So there we have to be satisfied with the one shot study. We have done one shot study for a chatbot particular experiment. But the results, yes, the results, you cannot confidently say that y is because of x. In one shot study, that problem is there. The next one is one group, but it's a good way. Next one is one group pre-test, post-test, in which you are conducting a test before the treatment. You are conducting an observation, taking an observation before the treatment and after the observation and after the treatment. So which means you will notice the change. In earlier case, you were not even noticing the change. And in this case, the number of problems are even more. There is history, maturity, selection bias, mortality, interactive, the instrumentation, mortality, the interactive testing effect and statistical regression. All these problems are there. The last one is static group comparison. So the control group has come. Generally it doesn't come in pre-experiment, but this is one of the case. In static group comparison, what is happening in static group comparison? Who will tell me?
So we take two groups, one control group and one experimental group. We subject the experimental group to the treatment and then take observations. Control group, no treatment, we just take observations.
Right. So very similar to the doctor case, but doctor actually, let's assume that doctor did not take the observation but directly gave the treatment. So observation means they did not conduct blood sample test. So observations are not there. Definitely he will look at the symptoms. So static group comparison is when the treatment is given to one of the groups, but there is a control group also going through the experiment, but observations are taken only post at time t2. So there are selection bias and mortality. If one could control those, then it will become a very good experiment. Now the next one is true experiments. True experiments where there is a randomization, where there is a control group. So we take care of many of these things. Just wanted to highlight one aspect. Let's say we are doing this one group pre-test, post-test. We have observations before and after. Let's say there are 25 people. You have observation before the experiment and after the experiment. You have 25 observations. What statistical test you will use here to see whether there is a significant impact, truly whether there is an impact of x1, although there are so many confounding variables, but just to see whether the change in the observations is substantial, what statistical test you will use? You have 25 observations from the same people who went through the experiment, O1 and O2. Same people, pre-experiment, post-experiment. What statistical test you will use to see whether there is a significant change in the y variable post the experiment? You have pre and post. Paired t-test, very good. So you will use paired t-test. We will learn about these tests, but it was very important to tell you because I am telling you experiment, but once you have data, how you will analyze the data? You should also know how to analyze the data. Simply you have to use paired sample t-test. When paired sample we use, when the respondents are same, pre and post. For the same respondent you are looking at their two readings, but if the respondents would be, let's say when we conduct for two different genders, we take reading on some metric variable, then we use independent sample t-test. In this case we are, so you should also not only know how to conduct the experiment, but how to actually, once you have readings, you should also know what is the right test to do. Mortality. Oh sorry, MT is, MA is maturity, main testing effect, sorry. Main testing effect, I is instrumentation, IT is interactive testing effect, SR is statistical regression. So true experimental designs, there is randomization of not only the respondents but also of the groups, and this is pre-test, post-test control group where only interactive testing effect will be there, which is a problem, otherwise there is no. History is not there. See, what you are doing is, control group is also going through same events that would happen during the course of experiment that are happening with the experimental group. So what you are doing is, you are not only taking the observations for experimental group, but you are also taking the observation for control group. If let's say some event would have happened here, it would impact both O2 and O4. Now you are O4 minus O3 when you are doing, and O2 minus O1, and you are using this particular for the total effect. T is total effect. You are taking care of maturity of history and many other effects. So this I can clearly say it is because of, when you are using control group, maturity and history gets taken care of. When you are using randomization, selection bias gets taken care of, and when you are using actually mortality also gets taken care of when you are using this control group. Is it? That's what is it? Mortality. Let's say if some people leave the experiment in the experimental group, but do not leave, the mortality would not be taken care of through the inclusion of control group. So maturity will be taken care of. Selection bias is taken care of because of randomization. Main testing effect will be taken care of because both are being told they are participating in the experiment. So, which one you are saying? Which mortality? One way of
regression towards the mean, that is taken care of.
In both, because when you do randomization, so you do not only select people at the extremes. The idea is it would be spread over both the So mortality, one ways to control is to make sure that you conduct the experiment with people who would not leave the experiment. Because in this way, if in the experimental group they leave, in the control group they don't leave. So the numbers would be different. So there will be still some problem. So mortality, one way is that you if you are conducting, let's say an experiment which is for an hour, you are wanting people to come to a facility, showing them ads, very less likelihood that some person will go in between and or will leave the experiment and so on. But if you are conducting a longer term experiment, 2 months, 3 months, there is likelihood.
Or we can just increase the sample size.
That is one way of increasing the sample size. But let's say if somebody doesn't leave, so it will be over representing. That problem also comes. But these are very, very small problems. One could actually have a little more sample size with the expectation that somebody leave. But small minor differences would be not be a big problem.
If there is a size of 50 people and if one leaves, then there might not be any noticeable.
Yeah, it will be very less, but whatever small will be there, it will show up in Y. So this is another true experimental design. This is post-test only control group. It has selection bias and mortality. How much time we have? So what is happening in this experiment?
Randomization is there, but we are measuring only after the experiment is done.
We are measuring only after the experiment is done. And randomization is there. Why is the selection bias there when randomization is done? In this case, yes, when randomization is done, generally selection bias is taken care of. Mortality is here because if experimental group somebody leaves the experiment. Selection bias should not come here. It might be, there has to be something else, because selection bias would only happen if you do not randomly select or randomly assign people to different groups. It may not be there. I think it might be a mistake, but just check it whether it will still be there. This will be there. Both are different. Previous one.
And this one.
I mean, sir, experimental group and control group are different.
Yes, both are different.
So how the selection bias would come? Because both are representing two different things, right? The selection criteria which we may be using single random sampling over there, and down there may be using another sampling.
No, the idea is so once we have the group, we randomly allocate them to two different groups as well as randomly allocate the experimental and control group to them. Both randomization is there. So the idea of selection bias would not be here when we do randomization, but that is one of the question. I think it should not be there, but just check it. Just check it, maybe in your textbook, just check it whether there is a chance for statistical bias, because when randomization we do both randomization in terms of allocation of sample to different groups and allocating the experimental and control group also randomly, this selection bias should not appear.
So maybe it could be because how we are randomizing or what system or instrument we are using, it would be based on that selection bias.
Possible. We'll check. You people check it and tell me. The idea is when we select people, we try to select people who have similar sort of background on their demographics. So you select 30 who have similar sort of background in their demographics, and then you randomly allocate. You do not select or similar sort of background on the variables that are central to that topic. So the sample that you select, you select a particular 30 sample here and 15 you put here. So this 30 also you select the ones who are similar in the demographics or similar on those variables that are related to your topic in hand. Because we cannot, 30 random people walking on the road, 30 people we select, not like this. 30 people who have similar sort of demographics, at least. The next one is quasi-experimental design. Now they are not the true experimental designs. True experimental is the best form of experimental design where we use randomization, control group, and what else we can, mainly we use randomization and control group, and even test units matching also we use in we could use in true experiments. But quasi-experiment are different from true experiments. One is quasi-experiment, we say quasi-experiment, which means they are not true experimental designs because of certain limitations in not able to do it in a true experimental way, but they are more generally field-based experiments. Field-based experiments, it's very difficult to control all the extraneous variables, but when we try to conduct experiments in a field setting, we end up doing quasi-experiment. What is a quasi-experiment now? One is, in quasi-experiment, there is no randomization of test unit. And the timing of the treatment presentation as well as which test units are exposed to the treatment may not be within the researcher's control. The timing of the treatment, at what time you will give the treatment, and which test units will be exposed to the treatment at that time, that is not within your control. What is in your control in quasi-experiment? Who are the test units who will be exposed to the treatments, and when the treatments, even when the treatments will be given is not under your, when the treatments are given and when the test units will be exposed to the treatment, this is not under your control. Neither is the randomization possible. So what is possible is on whom the treatments will be given and when you will take the observation. These two are under your control. Now what is the use of such a design when nothing is under my control, right? So in quasi-experiment, this generally done in field. So what is under your control and what is not under your control? Okay, whatever I said from them, what is under the experimental control? What is under the control of the researcher? What is under the control is on who are the test units? Who are going to be test units? That is under my control. And when I take the observations. But I do not have control over when the test units will receive treatment. I cannot do randomization. And I cannot control which test units will be exposed to treatment. And you see in this there is time series design, which means I take multiple observations before and after the treatment. Now what is the use of such when there is many things that is not under the control? Now the market research companies like Nielsen, they have a lot of panels who give them data on many questions on a periodic basis. Let's say in ADAR we want to see the impact of increase in the advertisement of a particular brand. Let's say Dove, again we select Dove. We want to see in ADAR whether double the amount of advertisement, what will be impact on the sales of Dove in the ADAR. So what we will do is, and let's keep it little simple, go to the time when only televisions were there was no YouTube or no digital mode, only televisions used to be watched. Just to think of this case, keep it very simple. So in ADAR, let's say the company selected about 1,000 families. So the test units, who will be the test units is selected by the company. Right? Who will be the test unit selected by company. But I cannot, but there is no randomization. These test units are there. I am not running first of all any control group, and I am not selecting these families randomly. I am selecting them based upon their availability for participating. Somebody who volunteers to participate in this experiment, I selected them. There is no randomization. Now from those families, observations are taken, let's say every 2 weeks, O1, O2, O3, O4, O5, observations related to purchase of a purchase in a soap category. The Dove brand soap, we want to see double the amount of advertisement, what will be the impact? Dove advertisements are running as it is, in whatever frequency it is running, and the observations are taken from 1000 families. O1, the interval is 2 weeks. So let's say it is time T1, T2, T3, T4, T5. Now in this 2 week period, the 2x advertisement was given to these thousands homes in the television screens of these 1000 people, 1000 families. Now when they will see the advertisement, which means when they will be exposed to the treatment, I don't know when they switch on. So that's why I said the timing of the treatment, when the channel will run the advertisement, it is not under my control. But I have told the channel increase the advertisement by 2x. The brand manager has told at this point of time, at time T6, increase the advertisement by 2x. Now when they will show the advertisements and when the test units will see when the families will see the advertisement, that is not under my control, neither the randomization. But I know they will be running entire day for 2 weeks, twice the amount of advertisements, and sometime test units will see it. I don't know at what time test units will see the advertisement, and I don't know what time they will release the advertisement. They might do based upon their own convenience, the channel. Twice the amount of advertisement is given. In this time, and then say this T7, the readings are taken again. And in this period, then again X level of advertisement continues, same as the before. Here I put only 2x. Then observations are taken T8, T9, T10, T11. Now you have multiple observations in this case. So you would want to see at this point of time in these 2 weeks when you conducted twice the amount of advertisement, what is the impact on sales and how long this impact will be there. After these 2 weeks, you are again bringing the advertisement back to X level. So you will be able to see the changes in the sales. This is an example of quasi-experimental design, which you conduct in field when you don't know when your respondents will see the advertisement, when the channel will give them the advertisement, so you will have to do quasi-experimental, right, moving forward, because you do not have control. Let's say you want to do on YouTube digital media, YouTube will not tell you, you cannot control when your ad will be shown at what particular time and when your users will see the ad. So the kind of experiments which you will be running with your audience on YouTube, let's say related to advertisement, they will be quasi-experimental design. And when we use a control group, then it becomes multiple time series design. It's very difficult to have a control group actually. But if you have, let's say, then it will become multiple time series design, where with control group you can control for many other factors, but it will become more expensive. Now why we are taking multiple observations? If you look at the screen, when we are conducting this time series design, multiple observations are taken before and multiple observations are taken after, and treatment is given in between. What is happening in A, B, C, D, E? In A, post-treatment, the effect is there and it is sustaining. You have an increase. In A, if you look at A, there was a certain level of observations, and after the treatment, the observations level went up immediately and are there still. In B, what is happening? The impact is there just the next 2 weeks of the increase in advertisement, but it came back to the same. So the duration by which the effect can be sustained can be known through multiple observations. If you look at C, in C what is happening? Immediately after the X treatment is given, the effect is not noticed, but it is noted after in the 3rd and 4th week, after a delay. So delayed effect can be noted down through multiple observations. In D, if you look at D, if you look at D, trend of D, and you take only the immediate observations, pre and post, what you will conclude? Increase. But what is happening? It is increasing on its own. This trend is like that, it is not because of D. So that is why we take multiple observations. So field experiments generally are good when we do with multiple observations and in a quasi-experimental way. Okay, so I will not discuss more about the experiments now. I will share the slides and the textbook, please read, because the initiation into this experimental design I wanted to give you so that you develop your own interest and carry on with that. It is not easy to conduct experiment, but if you develop your skill, there is nothing like that. So thank you everybody. We'll meet in the next class.